her student Jacob Daniels from University of North Texas. And so this title that is with a little bit more buzzword, including low-cost internet networks and satellite data, also Geo AI for spatial predicting of the PM 2.5. So a little bit about our project that is funded by NSF is focused on the investigations for the urban pollution island and urban heat island, their interaction patterns and drivers for metro areas in the Texas. For that region, particularly, there's a lot of heat waves that likely dryer the top soils, and that also frequently has been impacted by dust storms. So that we are focused on the climatology of the pollution as well as those extreme events. And so this talk we will focus more about the air pollution part. So this project, like we adopt a low-cost sensor, which is a commercial. It's called Purple Air. It's widely used commercial units that can offer the near real-time access of the observation using API from the commercial companies. And but this sensor unit also known have some kind of commonly known biases. This is a comparison between the EPA's standard values of the air quality stations with the purple airs, and you can see there's definitely overestimation of those low-cost sensors. So in order to get a good temporal measurements, so first the photos here that showing we put those different units in the cage and put the solar panel on the top to power the Wi-Fi transmitters so that we can have those units run at the same time. So we locate that case next to the EPA's standard air quality stations. So through this process, we are able to calibrate each amount of sensors and also against to the standard station observations generally improve their mean airs, and the scatter plot is showing generally have a very good agreements temporally. So next step, as several earlier speakers mentioned about a tremendous time actually effort involving citizens participate in this project. Our projects also have the same kind of time investment involving different activities, including host local training workshops, recruit the citizen science, and also we go to high school or senior centers to actually to showing how it works, how to demonstrate how to set up those, and also to trying to deliver some of the information to increase the local awareness about the urban living environment, including heat and pollution. And with those efforts, we were able to establish protocols to actually to design to set up individual sensor sites, including purple air and also the Hubble temperature moisture sensors within the solar shell here. And so generally, our study domain is a little bit north of Texas. You can see the upper map, and that's as a part of the Dallas metropolitan areas, but north of that county, that's about 4 times the size of New York City. And so we're trying to stratify the stations so that have a good representation of the different urban landscape, which can be very different from Europe's landscapes. And so the rural areas is representation photos is showing more about the rural sites, suburb that have the second and fourth photos. And actually, our urban side is still relative sparse compared to many European cities. So with those efforts, that we are able to, relatively evenly distribute the stations about over the general urban, suburban, and rural areas. So by now, we totally have about more than 90 stations. So involving 60 private citizens and 12 K2 school campus, and 16 city properties, and 2 state parks, and 3 research units. And because there's many restriction limitation about where we can set up location, particularly in people's backyard, require Wi-Fi assessment. So you can see examples where we're trying to set up those stations. But generally, we follow protocols that best to able to match to make sure all the stations have some comparable measure height without the blocking of trees and etc. With the first year we established this network, and the second year that this is our second year that we're able to collect some of the data set. So generally mapping purposes is we're actually using this over 90 station locations and try to produce a little bit more spatially comprehensive PM 2.5 maps, and using some known factors, which including airflow, optical depth, and other surface static urban properties, including tree distribution, building morphologies, and traffic-related indexes. And one of the challenges is for the set measurements, LD, as in column-based, that's relatively positively correlated to the near surface conditions. So that's why we consider this as a variable. But satellite come with some often missing data. The lower figures is showing the May 3rd is a clear sky that we have a completely spatial representation of AOD. But the day earlier that showing have a scattered clouds. So here Daniel and Liang has developed a machine learning approach that calls spatial temporal long short-term memory CNN autoencoded models to reconstruct the missing data. So the experiment result is showing, first we have a clear sky images and artificially create those clouds with different distribution, then reconstruct it. And generally showing this approach compared to other benchmark performances at the daily weekly is generally shown very well. And also it performs very well for cloud coverage that's in 90%. So with those AOD data, daily data reconstructed, we'll also be able to extract the morphology information from LiDARs with very large data process. So generally we can get the tree distribution height and building morphology as well across the entire domain. For potential missing data also with locations, also Liang's group also fly the UVA with drones to create a much finer spatial map of the building height and vegetation information. In addition, this project also using NAIP data, which is airborne products at 1 meter spatial resolution. Based on this data, generate the land cover types of 8 different land cover use and able to characterize a horizontal profile of each site characters. Using those daily LD and static surface vertical morphology data, and also some indexes related to road networks, then we can blend it those data set in another machine learning tools. This is using the multi-scale tension enhancer CNN approach. So this is the output of the map, and generally performances with the spatial map. Here is our model. This is the general spatial GIS grading interrelations. It is showing have a significant improvement in general. And so this is just an example of that application. We have simulated a few days PM 2.5 results. So the panels on the right side, the first column represents the census block family incomes. The second column represents the average PM 2.5 concentrations for the urban, suburban, and rural categories at different rows. So there are some of those neighborhoods or blocks that actually showing high exposures. And statistically, this is showing for the suburb and urban categories. We can see a statistically significant negative correlations that suggest some lower income families or neighborhood actually have some higher PM2 exposure. But note that this is just a representation of few days samples. But based on this, data pipeline structures, we're able to generate a little bit long-term records of the PM maps, and also including those that represent the extreme events like dark storms. And also, there's other attempts in trying to link outdoor map, like predictions into indoor air pollution. In U.S., particularly in Texas, AC is really have more than 90 or 95 prevalence overall, but those that's lack of really ventilation in general. But this is what we're trying to link, and this is the end of this study. And there's this papers actually have more details if you'd like to read. And any air pollution data and modeling work, please feel free to reach out Professor Lu Liang and her Twitter account. Yeah. Thank you very much.
Thank you. There's time for questions.
When you utilize your AOD data, you have converted the data set from column density back down to surface concentration.
I believe it's just the original AOD, but spatially failed with.
Also, you use a Leiqiu regression model.
This is we're just using the AOD column based as a variable to predict the surface PM 2.5. So there's no other transfer process to the bottom layers before putting the model.
Yes, I have a question regarding the purple air sensors. Mm-hmm. It's a low cost, but you have a lot of them, so you can make clever selection, add quality flags, etc. Mm-hmm. I know that they have issues with high relative humidities, that aerosols will grow artificially due to the high humidity. Do you do any correction for that?
Yes. So that's probably the cage with different. We're using a more like a data-driven approach to compare the local stations to actually calibrate, to have a algorithm to calibrate the impacts. Not necessarily, I don't know, is from moisture, but in general. So we calibrate that before we deploy those sensors to different individuals' location. It may be there's some spatial variation of the moisture, but we're not able to account for that. Hope that answers your question.
Probably also drier than what I experienced in the Netherlands. The very high humidities are a bit rare.
Yeah, Dallas area is a little bit drier. Definitely drier than Houston. Okay.
Okay, thank you. Thank you very much. The next speaker, well,